Welcome back. Here we're going to go over proportions. Proportions are also sometimes called advanced ratios. Now, a proportion is simply the result of two equal ratios. Some example of these are 1/2 equals 2/4. This is an example of a proportion. And a proportion, we have a ratio on one side, 1 to 2, and a ratio on the other side, 2 to 4. A ratio is also called a fraction. This is nothing to get excited about because we've seen these before. Another example of a proportion is 2/3 over 4/6. While they're both fractions, they're actually both numerically equal. So a proportion is the result of basically two equal ratios. We always want to remember that. And most proportions we solve involve an unknown quantity. So that's actually what we'll be doing here. We'll be learning to solve a proportion with an unknown quantity. So don't get excited when you see this. They're actually quite simple. So let's jump into a couple. Let's say we have the proportion 7 over 5 equals 4 over x. Okay, x is an unknown quantity, but we can solve for x by cross-multiplying. So we're going to multiply it across the equal signs, numerator to denominator and denominator to numerator. This is called cross multiplication, and you'll actually see it a lot through mathematics. So we're going to get 7 times x equals 7x equals, and then the bottom one, 5 times 4 is 20. So we simply multiplied right here and multiplied right here, putting our equal sign in the middle. Now we can solve for x. We know this from solving multi-step equations. We simply divide here by the coefficient, which will cancel this and will relieve x by itself on the left. Whatever we do on one side, we have to do on the other side. So we'll divide by 7 over here. That keeps the equality, the equation balanced. So it keeps the equality of the equation. And we have x equals 20 over 7. Okay, and that's our answer. 20 over 7 is the exact quantity that we can plug in for x to make the two ratios equal. And once again, like we said earlier, you can actually plug this in and check our answer just to make sure that we're correct. So you always want to take the time to do that. Let's look at a few more. Let's say we have the proportion 5 over 18, and that equals y over 9, and we want to solve for y. Well, how do we do this? Well, we simply cross multiply and solve. We have 5 times 9 equals 18 times y. So 5 times 9 is 45, and 18 times y equals 18y. Variables on the right side, but things will work the same. We handle it the same way. Divide both sides by 18. These cancel, so we end up with y equals 45 over 18. And again, we always want to simplify. We always want to leave our answer in simplest form. And we can actually factor out a 3 out of the top and the bottom, which gives us, well, we can factor out again 15 over 6. We can factor out another 3, and this gives us 5 over 2. And that's the answer. That's what we can plug in for y, which will give us two equal ratios, which is the same thing as a proportion. Let's take a look at 2 over x equals 11 over 13. Okay, what do we do here? Basically, we just cross multiply. There's not a whole lot to proportions, but we want to get the hang of the steps. 2 times 13 is 26 equals x times 11 is 11x. Now that we have our proportion set up like this, there's no more fractions. We can solve for x. Divide both sides by 11. X equals 26 over 11. Okay, not a whole lot to proportions. Let's do a couple more just so we can bring it on home. Let's see. Let's say we have z over 6 equals 1 over 78. Okay, so what do we do here? Z times 78 equals 6 times 1. So we get 78z equals 6. Divide both sides by 78. That isolates our variable z, which gives us 6 over 78. And we can simplify this. We can pull a factor out of 6 out of the top and the bottom. That'll give us a 1 over 13. Okay, that's our answer, making our two sides equal. Okay, let's take a look at this one. Let's say we have 1/2 divided by 3. That's our ratio, 1/2 to 3. We have x over 5 on the other side. Okay, here we have a complex fraction on the left. This isn't anything to write home about. We still know how to multiply fractions. So let's go ahead and cross multiply. We're going to multiply 1/2, the quantity, 1/2 times 5 equals 3 times x. So 1/2 times 5 is 5/2. Simply multiplying the numerators. 3 times x is 3x. Let's isolate the variable by dividing both sides by 3, so that'll cancel. X equals, now let's go ahead and turn this into a fraction so we have a fraction on top and bottom, and we know how to multiply, divide rational numbers. What do we say? We rewrite the numerator, and we don't ask why, but we flip the second and multiply. 3 over 1 becomes 1 over 3. Then we can simply multiply fractions across the top. Numerator times numerator gives us 5. 2 times 3 equals 6. And 5 over 6 is our answer. If you're confused how we did that, you can review the dividing by rational numbers section for a quick refresher. But we should know how to do this. Let's take a look at this one. Let's say we have 5/3, a ratio of 5/3 to x over 2. 5/3 to x over 2 equals the ratio 4/9 to 1 over 10. Okay, don't get excited here. We simply cross multiply the same way. Multiply this quantity times this quantity, and we multiply this quantity times this quantity. Okay, take it one step at a time so we don't make any mistakes. We have 5/3 times 1 over 10 equals, we're writing it out just so we don't make any mistakes, equals x over 2, cross multiplying, times 4 over 9. 5 times 1 is 5. 3 times 10 is 30. And on this side, x times 4 is 4x. 2 times 9 is 18. All right, let's go ahead and simplify as we go just to make our job a little easier. 5 over 30 is equal to 1 over 6. We simply factored out a 5 out of the top and the bottom. And we can factor out a 2 out of the top and the bottom here, which gives us 2 over 9x. Okay, we want to isolate x, so we're going to multiply by the reciprocal. Reciprocal of 2 over 9x is 9 over 2. We got to do the same thing on both sides. Multiply by 9 over 2. Sorry about that, we're running out of room here. All right, so on the left side, we have 9 times 1 is 9. 2 times 6 is 12, equals. This cancels with this, so we're left with x. We can actually simplify this, pull out a 3 out of the top and the bottom, which will give us 3 over 4. And that's our answer. Okay, there was a few more steps involved in that one, but don't get discouraged here. We simply take what we know. We know how to multiply fractions. We know how to solve for x when we're being multiplied by a fraction. We know how to divide. We know how to simplify. So we know we have the tools to do all this. So let's just take it one step at a time. And I'm confident that we won't make any mistakes, and we'll get this down. Proportions are very important, and they're actually not too difficult. Well, let's take a look at another one. Let's say we have 0.5x divided by 3 over 4. So our ratio is 0.5x to 3 over 4. On this side, we have 1.2 divided by 8. Okay, here we have a mixed bag of integers, fractions, decimals. Let's go ahead and begin by converting the decimals to fractions. If you've noticed yet, I prefer fractions to decimals. I just find them a bit easier to work with. So let's convert 0.5 to 1/2 times x over 3/4. And we can convert 1.2, and that'll give us 1 1/5, or 6/5, I believe. 1 1/5 is 6/5. So it's 6/5. Let's go ahead and convert 8 to 8/1. So now we have 4 fractions. So we know how to deal with this. Let's multiply here and cross multiply here. 1/2 times 8/1 is 8/2 x equals 3/4 times 6/5, so 3 times 6 is 18, and 4 times 5 is 20. Again, we can simplify as we go. 8/2x equals 4x. Simply factored out a 2 out of the top and the bottom. And then 18/20, if we factor out a 2 out of the top and the bottom, we get a 9/10. And then we simply divide by 4 on both sides. That'll isolate our variable x. And let's go ahead and write 4/1, so we're dividing by a fraction here. And we know we rewrite the 9/10, and we don't ask why, but we flip the second and multiply. 4/1 becomes 1/4. X equals 9 times 1 is 9. 4 times 10 is 40. And x equals 9/40. Okay. So what did we learn here? Well, we went over proportions, also called advanced ratios. Basically what it is two ratios that are equal to each other. And we've seen plenty of these in this form, but what we're really interested in is proportions that involve one or both ratios sometimes, but at least one of the ratios has an unknown quantity. So what we can actually do is cross multiply and end up solving for that quantity. Okay, so go over these a few times. I'm confident that you'll get it because these aren't actually really difficult at all. We're just taking what we know and applying it to something. This is called proportions. So I'll see you in the next video.